Hey everyone, today we'll be discussing ionic bonding and ionic molecules. Now, what are ionic bonds? Specifically, an ion is an atom with a positive or a negative charge. For example, you have a sodium ion with a positive 1 charge and an oxygen atom with a -2 charge. Ionic bonds result from a transfer of electrons between ions so that they can become stable. This is typically between a metal and a nonmetal. You can see here that when magnesium atom gives up its two valence electrons to oxygen, they both become ions with charges. What are ionic compounds? This is when ions bond in order to become stable and follow the octet rule. The octet rule states that an atom has to either gain or lose electrons in order to get a stable configuration of 8 valence electrons. These ionic compounds are also known as salts. An acronym that you can use for ionic compounds is BARF. When you break bonds, you need to absorb energy, and when you form bonds, you need to release energy. Some ionic properties are known to have like high melting and boiling points, having a crystal lattice structure, forming ionic solids, being soluble in water, conducting electricity in solutions or in a molten state, and being brittle. Here, you can see the crystal lattice structure of the ionic compound sodium chloride. Ionic character. This is just saying how ionic the bond is. It's determined by the electronegativity difference, so the greater difference creates a more ionic bond. Between sodium fluoride and lithium fluoride, sodium fluoride would be more ionic, since it has a greater difference in electronegativity than lithium fluoride. Polyatomic ions. These are groups of nonmetals covalently bonded that have a charge. You can find these on Table E of your reference table. Polyatomic ions can have either a positive or a negative charge, so they can lose or gain electrons. Some examples would be ammonium that has a positive charge and nitrate that has a negative charge. Now, here is some practice naming ionic compounds. Feel free to pause the video while you do so, and in a second I'll switch to the answer slide. Here are the answers to the practice. You have lithium fluoride, sodium nitrate, aluminum oxide, ammonium chloride, magnesium sulfide, and ammonium cyanide. Oxidation numbers. These are the possible charges an element can have. Most of these numbers correspond to the group number an element is in, while the others can be found on the periodic table. In an ionic compound, the charges of each element must add to zero. So over here, you have calcium sulfide. A calcium ion has a positive 2 charge, while a sulfide ion has a negative 2 charge. And these two charges add up to 0. Here you have aluminum oxide, and you have two aluminums with each charge of a +3. Over here you have 3 oxygen ions that have charges of -2 each. So the 2 aluminum ions add up to a +6 charge, while the 3 oxygen ions add up to a -6 charge. So those two add up to 0. Lewis dot structures are ways to show how electrons are transferred during bond formation. When drawing compounds, each element must be drawn in its own brackets, with its corresponding charge in the top right. Metals are typically drawn without dots around because they lose electrons, while nonmetals are drawn with 8 dots around them because they gain electrons. When drawing diagrams for polyatomics, put brackets around the entire polyatomic ion and do not separate the elements. Here you have an example of sodium chloride. Sodium has a charge of +1, so it lost an electron, while chloride gained an electron due to its -1 charge. Same over here with magnesium fluoride. Magnesium has a charge of +2, so it lost 2 electrons. Over here you have 2 fluoride ions. Each of these lost 1 electron, so it adds up to a -2 charge, which +2 plus -2 gives you a total of 0. Metallic bonding is a type of attraction between delocalized electrons and positive metal ions. This forms metallic solids or alloys, which are solid solutions that usually contain more than one metal held together by metallic bonding. Over here, you can see the positive metal ions, and then you have the small delocalized electrons surrounding them. IFAs, or intermolecular forces of attraction, are the attractive forces that hold together molecules. Ionic molecules experience ion-ion forces, or attractions, which form ionic solids. You can see the lattice structure of sodium chloride held together by these ion-ion forces. Recap of the video, you have what are ionic compounds and bonds, properties of ionic compounds and ionic character, polyatomic ions and oxidation numbers, Lewis dot structures, metallic bonding, and IFAs. I hope this video helped you guys out. Thank you, and bye.